Hi everyone, welcome to this week's lesson, and today we're going to be looking at Pythagoras Theorem and also circles and parallelograms. So the lesson will be split into two parts. After we go through the theory, we're going to go to exam questions and their solutions. So the first thing that you'll see on the screen there is Pythagoras Theorem. So remember that a right angle is always 90 degrees, and we donate right angles in the diagram like this. So you can see it there. It looks like this, or sometimes, I'm just going to draw it on the screen here, sometimes you'll see a right angle written like this either. So both of those mean that it's a right angle, and a right angle is 90 degrees. So a right angle triangle is one in which one angle is a right angle. So an example of a right angle triangle would be this one here. So one of those angles is a right angle. So we're going to look at the example there. So I'm not going to show the solution, we're going to do the solution out and then we'll look at the solution afterwards. So find the measure of the unknown angle in the following triangle. So this angle here is 40 degrees. This angle has the right angle sign, so that must mean that that's 90 degrees. And what we're being asked is to get the measure of the unknown angle, so this angle here. So we'll call this angle x. So we know that there's 180 degrees in total in a triangle. So if we added the three angles together, we'd get 180. So if we added 40 degrees plus 90 degrees plus x degrees, we don't know what that is yet, we would get 180 degrees. So what we'll do is add 90 plus 40 and you get 130. So 130 degrees plus x degrees gives us 180 degrees. So in order to get the unknown, which is x, you bring the 130 over across the equal sign and it becomes a negative. So it's going to be 180 degrees, take away 130 degrees. X is 50 degrees. And if we scroll down here, yeah. So the missing angle is 50 degrees. Okay, so we're going to scroll down now. So in a right angle triangle, we already know how the angles are related. So how are the sides of a right angled triangle related? So the following theorem answers this question. So this is Pythagoras' theorem. So if C is the length of the side opposite the right angle, which is here, so C is here and the right angle is here, then A and B are the lengths of the other two sides. Okay, so I'm going to draw out that triangle along the side here. So the right angle is here. They're saying that this side is known as C, and this side we'll call A, and this side is B. Now, Pythagoras' theorem states that the square of the hypotenuse, which is C, so C squared, is equal to the sum of the other two sides. So sum means adding together. So it's going to be is equal to A squared plus B squared. And that's Pythagoras' theorem. Now, if we were to label them correctly, C here is known as the hypotenuse. And the hypotenuse is always the side that's opposite the right angle. So I'm just going to write that down. So the hypotenuse is always, so this never changes, so it's always the side opposite the right angle. And in this case, C is the hypotenuse. So the hypotenuse squared is equal to the sum of the other two sides squared. Okay, I'm going to move on. So this theorem applies to any right angled triangle. Here are some examples. So what is the value of C in the following diagram? So C. Now what is C first of all? It's the side that's opposite the right angle, which means that C is the hypotenuse. So we're going to just label it there. So the rule is C squared is equal to A squared plus B squared. So I'm going to call 4, we'll call that A, and we'll call 3 B. Now it doesn't actually matter which one you call A and which one you call B because they're both on the same side. So if we were to fill that in, we're going to get C squared is equal to A squared, which is 4 squared, plus B squared, which is 3 squared. C squared is equal to 4 squared, which is 16, plus 3 squared, which is 9. So then you get C squared is equal to 25. So C is equal to the root of 25. So C is 5. That last little bit cut out there, so 5, C is 5. So that's the answer to that one. Okay, so I'm going to move on. Another example. So what is the value of x in the following diagram? So it's this side you're looking at this time. Now remember, The side opposite the right angle, which is 7, this is the right angle here, that's the hypotenuse. So we say c squared is equal to a squared plus b squared. Now remember, we always said c is the hypotenuse, which is 7 in this case. So let's fill it in. 7 squared is equal to, I'm going to call this a and call this b. So a is x squared plus b squared, which is 5, so 5 squared. 7 squared is 49. 49 is equal to x squared plus 25. So we're going to bring numbers to one side and letters to the other. So I'm going to bring the 25 over beside the 49. 49 take away 25 gives us x squared. 49 take away 25 is 24. That gives us what x squared is. Now we want what x is, not what x squared is. So x is going to be the root of 24. And because that doesn't give us a whole number, we can just leave it in that format, which it has in the answer here. Okay. So now we're moving on to right angles and semicircles. Okay, so the first thing we're looking at is Corollary 3. Now a corollary is something that has already been proved. So if BC is the diameter on the circle of the circle, and A is another point on the circle, then they're saying the angle BAC, so that we look for the letter in the middle, the angle BAC is 90 degrees. So what they're saying here, let's look at this. If BC is the diameter of the circle, so BC, if we were to draw a line from B to C, that's a diameter clearly, and A is another point on the circle, which is here, then they're saying the angle BAC is 90 degrees, and it's evident there by the sign for 90 degrees. Okay, we'll go on to the next one. So if the angle BAC is 90 degrees, which is this angle here, then BC is a diameter of the circle. So it's kind of the opposite of what we just did there. So if the angle BAC is 90 degrees, so this is 90 degrees, then they're saying the side BC is the diameter of the circle. Okay, so we're going to go to an example now and a solution. So suppose that A, B and C are points on a circle of radius 5 and that AB is the diameter of the circle. If they're saying the length of BC is 6, they're asking what the length of AC is. So this is what we're looking for here, this length, AC. Now they're telling us that the radius of the circle is 5. So the radius is, so the midpoint, or we say the center of the circle will be roughly here. So this distance here would be 5. And this distance would also be 5 because they're both radii or radius. Okay, so we know that this total distance here would be 10. Okay, so if I was to redraw that triangle, so just draw it here. So something like this. And we know that this angle is a right angle. We know that this distance is 10. We know that this distance is 6, and we're looking for this distance here. I'm going to call it x. So we use Pythagoras Theorem because it's a right angle triangle. Now, the hypotenuse is always the side opposite the right angle, which is this one here, because it's opposite that right angle. That's 90 degrees. So the rule is c squared is equal to a squared plus b squared. So 10 is obviously c, that's the hypotenuse. I'll call x a, and I'll call 6 b. Okay, so we're going to slot it into the formula. C squared, which is 10 squared, is equal to a squared, which is x squared, plus b squared, which is 6 squared. 10 squared is 100, is equal to x squared, plus 6 squared is 36. So now what we're going to do is bring the numbers to one side. So 100 minus 36 is equal to x squared. 100 take away 36 is 64. So 64 is x squared. So if x squared is 64, then x is going to be the root of 64. Put that into the calculator, you'll get 8. So this length here is 8. Okay, now we're on to parallelograms. So a parallelogram is a quadrilateral, which means 4 sides, A, B, C, D, with the property that AB is parallel to CD. So AB, I'm going to just use the highlighter, is parallel to CD. And also they're saying that BC, which is the top one here, is parallel to AD, which is here. So I've highlighted the 2 green are parallel and the 2 blue are parallel as well. If we extend the sides of this parallelogram, we can observe that the marked angles A and B are equal because they are corresponding angles. The angles at B and C are equal because they are alternative angles. See the lesson on transversals for more. Okay, so we'll just look at this example here. So the angles B and C, so this angle here and this angle here, they are equal because they are alternative angles. And also the angles A and B, which are A and B here, they are equal because they are corresponding angles. So they're all the same. Now we also know that the angle DAB, let's find that, so DAB, which again is this angle here, plus the angle ABC, so the angle ABC is going to be this one here, is equal to 180 degrees because it's a straight angle. Okay, I'm going to keep going. So another example here. If PQ or S is a parallelogram and the angle SPQ is 70 degrees, which you can see on the diagram there, what are the measure of the other angles? Okay. Well, if the angle SPQ, which is this one here, this is 70 degrees, that means that this angle here is also going to be 70 degrees because the rule is opposite angles in a parallelogram are equal. I'm just going to write this rule out. So opposite angles in a parallelogram are equal. So what that means is 70 degrees. So for this angle is going to be the same as this angle here, which is also 70 degrees. Now, there are 360 degrees in a parallelogram. I'm going to write that down as well. So there are 360 degrees in a parallelogram. So we have dealt with 140 degrees because 70 and 70. So 360 degrees take away 140 degrees will give us 220 degrees. So that means that there's 220 degrees left for this angle and this angle. Now because they're opposite angles, they must be equal to each other. So this angle here is equal to this angle here. So if they're the same, it must be 220 degrees divided by 2. And that gives us 110 degrees. So that means that this angle here is 110 and this angle here is also 110. And that's all the angles measured. And you can see there in the solution that those are the answers. Okay. So we're on to exam papers now. So the first one I have there is 2011, paper 2, question 9. Okay, so 4 shapes are shown. We have a parallelogram for A square for B, a rectangle for C, and a rhombus for D. So tick below to show the shapes for which the statements are always true. So the first one there, the diagonals bisect each other. So if they're bisecting each other, it means that each diagonal cuts the other into 2 equal parts. So that is true for a parallelogram. It's also true for a square. It's also true for a rectangle. And it's also true for a rhombus. So you have 4 ticks to put into that first one there. Okay, so the next one, opposite sides are equal in length. So that is true for a parallelogram. It's true for a square. It's true for a rectangle. And it's also true for a rhombus. So all opposite sides are equal in length. Now the next one, all sides are equal in length. That is not true for a parallelogram. And it's kind of obvious if you look at it there, like this side and this side are equal. But if you look at the other sides, they're visibly longer. So that is not true for the first one. So I'm just going to put an X in there. For a square, all sides are equal in length. We know that. So we put a tick there. For a rectangle, again, quite obvious. This side and this side are equal, but the other 2 sides, they're longer. So that is not true for that one. So I'm going to put an X there. And for D, so for a rhombus, all sides are equal in length as well for that one. So put a tick there. So then all diagonals are equal in length. So let's have a look at the parallelogram first. Okay, this one is not true for parallelogram, and I'm going to show you here. I'm just going to draw a diagram. Okay, so if we were to draw a diagonal there and a diagonal here. So this diagonal would be equal to this diagonal. But this diagonal, not necessarily. So this one would be equal to this one. But they're not all the same in length. Okay, so that's a no for that one. For a square, the diagonals are all equal in length. So we'll put a tick on that one. For a rectangle, they are all equal in length. And for a rhombus, they are not equal in length for the same reason as the parallelogram. So then, opposite sides are parallel. So for a parallelogram, this is parallel to this is parallel to this. That's true. For a square, this is parallel to this, and this is parallel to this. That is true. For a rectangle, this is parallel to this, and this is parallel to this. That is true. And finally, a rhombus, this is parallel to this, and this is parallel to this. So that is also true. So I think that's the full question. It is. So we're going to go on to the next one now. So the next one I have here is 2013, paper 2, question 12. So for this question, it's asking us to write the answers onto the grid. So choose the correct terms for A, B, and C from the following list. So the first word we have there is a radius. Second word is diameter. Third word is circumference. Fourth word is center. And the last word is a chord. So I want to look at the word chord here first. So a chord is a line segment joining 2 points on a curve. So it's a line segment. Line segment joining 2 points on a circle, should I say. So it's line segment joining 2 points on a circle. So if we look at that circle there, there's a point here and there's a point here, and the line joining it is A. So A is a chord. Now in terms of what a radius is, so a radius is the distance from the center of the circle to any other point on the circle. And that is going to be B here. So that's radius. Now, C is obvious, it's the center of the circle. So C is going to be the center. Okay, so for part B of this question, fill in the missing angles in the diagram and write the answers into the grid. Okay, so the first one there is X, so it's this one here. Now, as you can see, X is vertically opposite 70 degrees, so that must mean that X is the same, so it's also 70 degrees. Now, if we look at W, W is vertically opposite 35 degrees, so W is going to be 35 degrees. So then it's asking us to get what Y is. Now, you can see here that this whole angle makes a straight angle, which is 180 degrees. And we've just found out that W is 35 degrees. So 35 degrees plus this portion here, which is Y, plus 70 will give us 180 degrees. So I'm going to write that in the workings. So 35 degrees, which is W, plus Y degrees, which is what we're looking for, plus 70 degrees gives us a straight angle, which is equal to 180 degrees. So let's bring the numbers to one side and letters to the other. So Y degrees is going to be 180 degrees, take away 70 degrees, because I'm bringing it over to the other side, minus 35 degrees. So Y is equal to, so put into your calculator, 180 minus 70 minus 35, and you will get 75 degrees. So Y is 75 degrees. Now, you can see here for Z, so Y is vertically opposite Z. So that must mean that they're equal. So if Y is 75 degrees, then Z is also 75 degrees. So that's that full question done now. Oh no, I'm wrong actually. There's more. So we're on to part C. Oh, this is actually a longer question than I thought. So part C and part D. So the measurement of the sides of 4 triangles are as follows. So triangle A has sides 5, 3 and 4. Triangle B has sides 5, 6 and 5. Triangle C has sides 5, 6 and 7. And triangle D has sides 5, 6 and 8. Now it's asking us which one of these is an isosceles and give a reason for your answer. Now first of all, what is an isosceles? So an isosceles is a triangle where you have two sides that are equal. So that must mean that two of the sides must be the same value. So the only one that I can see there that has two of the same value is triangle B, because it has two sides that are 5. So the answer there is triangle B, and the reason is because two of the sides have the same value. And I'd put in here i.e. 5, so you just know what you're talking about. Okay, so we're on to part D. Cian used a protractor to measure the angle alpha in the diagram below. His answer was 100 degrees. Okay, so he's saying that this angle here, alpha, is 100 degrees. Do you agree or disagree with Cian's answer, and give a reason for your answer? Okay, by looking at that, you should know that that is less than 90 degrees, because a 90 degree angle looks like this. So 90 degrees would be that angle there. That's 90 degrees. Now this angle is clearly less than 90 degrees. So that angle is less than 90 degrees. So I would tend to disagree with Cian's measurement. And the reason is because this angle is less than 90 degrees, and the proper name for that angle is an acute angle, so i.e. an acute angle. Okay, so there's actually more to this question, E and F, and then we're done. So theorems on your course can be used to find the measure of the angles in the diagram below. Write down in your own words any theorem that you could use to find one of the missing angles. So okay, let's have a look here. We know that the sum of the angles in a triangle add to 180 degrees. So we know that this angle plus this angle plus this angle equals 180 degrees. Now we also know that this is a straight angle and that is also equal to 180 degrees. So you could say here either 3 angles of a triangle add up to 180 degrees. So 3 angles of a triangle add up to 180 degrees. Or you could say that the exterior angle, which is y, is equal to the sum of the two interior opposite angles, which would be 60 and 73. So the exterior angle is equal to the sum of the two interior angles. And the last part, find the measure of each of the following angles in the diagram in part E above and show your calculation. So for x, we know that 73 plus 60 plus x is equal to 180 degrees. So we're going to bring all the numbers to one side. So x is equal to 180, take away 73, take away 60. Put that straight into your calculator and you will get 47 degrees. So 47 degrees for x. Now, if x is 47 degrees, we can get what y is, because the bit highlighted in green there, that is a straight angle. We know that it's 180 degrees. So y is going to be 180 degrees minus the x part, which is 47. And again, you can put that straight into the calculator. 180 degrees minus 47 degrees is 133 degrees. Now, we are at the end of the question. So I think we have another one here to do. So this is from 2014 paper 2. Okay, a circular table is shown in the diagram below. Aoife is trying to find the centre of the table. She constructs the right angle triangle PQR as shown. QR is 1 metre, which is demonstrated here. The angle RQP is 90 degrees, which is denoted here by the right angle. And she measures QP and finds that the length of QP is 0.75 metres. Okay, so Aoife says that the centre of the circular table must be on PR. Explain why Aoife is correct. Okay, well, we were told that the angle PQR was 90 degrees, which means that PR must be a diameter, or is a diameter. And for that reason, the centre of the circular table must be on PR. Okay, on to the second part. Use the theorem of Pythagoras to calculate the length of PR. Give your answer in centimetres. Now, we were given it in metres, so we need to convert it to centimetres. So, first of all, 1 metre we need to convert to centimetres, and 0.75 metres we need to convert to centimetres. Okay, so there are 100 centimetres in a metre, so that's 100 centimetres. And then 0.75 metres is 75 centimetres. So I now am going to redraw the triangle that's on the circle here. So we have the triangle QPR. So I'm just going to draw it here. And this is the right angle here. So this is 75 centimetres. This is 100 metres. And what we're looking for is this. I'm going to call it X. Now, if we label correctly, so this is the right angle, which means that this is the hypotenuse. So if we use Pythagoras' theorem and the correct notation, that's going to be C. We call this A, and we call this B. So C squared is equal to A squared plus B squared. So if we put that into Pythagoras' theorem, it's going to be, so C squared is equal to A squared, which is 100 squared, plus 75 squared. And this is working in centimetres. So then C squared, which is PR, is going to be 15,625 centimetres. So C is going to be the root of 15,625 centimetres. So C is 125 centimetres. And C is the same as PR. So PR is equal to 125 centimetres. So then it asks to find the radius of the table. So PR is a diameter, and that's 125 centimetres. So to get the radius is going to be the diameter divided by 2. So that's going to be 125 centimetres divided by 2. Put that into the calculator, you get 62.5 centimetres. Okay, so that's all we'll have time for today. So I'm going to attach some extra links to extra video tutorials and extra material that's on the website. So I'd highly recommend that you follow that. And I will speak to you next week. Have a good week.